Hello and welcome to Festive Tech Calendar, the Semantic Kernel session. It is an honor for me to present this session for Festive Tech Calendar. You can find more about this series of presentations, very cool, very nice presentations at festivetechcalendar.com. Today we are speaking about Semantic Kernel. I'm going to present you a small workshop of how we can utilize a Semantic Kernel. A quick introduction on me. My name is Konstantinos Passadis. I live in Athens, Greece. I'm a solutions architect. Various certification from Microsoft Azure, M365, DevOps, also other providers. I'm also an MCT trainer and a Terraform certified associate. You can find more in my LinkedIn profile and in my blog, which I present various solutions for Azure M365 and DevOps. We have also an Azure Innovators Hub named as Azure Innovators Hub in Meetup. You can find it, and of course, you can be accepted as a member in no time. Let's make our quick introduction here with Semantic Kernel. It is an open source SDK that allows us to easily combine AI services, for example, OpenAI, Azure Open AI, and Hugging Face, with our programming languages, C Sharp and Python. We have also sample code in the GitHub repo from Microsoft, so you can go there and find what you need. We can create our AI apps that combine the best of both worlds. As you can understand, Semantic Kernel is an orchestrator. It has been engineered to allow developers to flexibly integrate AI services into their existing apps. Semantic Kernel provides a set of connectors that makes it easier to add memories and models. Semantic Kernel is able to add a simulated brain by this way into our app. Semantic Kernel always also makes it easy to add skill in our applications with AI plugins that allows us to integrate with the real world. The plugins are composed of prompts and native functions that can respond to triggers and perform actions. In this way, plugins are like the body of our AI app. You can find also more in the directory in GitHub from Microsoft. A small example here, using AI models, plugins, and memory all together with Semantic Kernel, we can create somehow sophisticated pipelines that allows AI to automate complex tasks for our users. We could create a pipeline that helps a user send an email to their marketing team. For example, we can use memory to retrieve information about the project and use Planner to auto-generate the remaining steps using available plugins. At the end, we can display a success message back to our user in our app using a custom plugin. Today's architecture is quite similar. We have a React web app that displays, a learning aid, for example, a learning aid app that displays some tutorials. Once the user clicks the tutorial link, we have control over the prompt that it is sent to OpenAI with the use of a function app written with required plugins for Semantic Kernel, and then the message is returned to our React web app. We're using Terraform, React, Azure Functions, Container Registry, and Container Apps to host our React app, and of course Azure Open AI. Now, let's see our deployment in VS Code. Here we have our React app. You can see that the only thing that we need in the environment variable is to be able to hit the Azure Functions API endpoint we created. Here is our init.py code, but the important thing is right here. We're using a secondary code or function, whatever you can name it. We name it as engage, and here we are taking the input from the GitHub repo from Microsoft, where we set the prompt coming as a user input from the React application. Let's see now the React application input. Let's see here. It is from the app.js, and here we can see that we have our main application.js file. Let's go to quizzes. You can see here that we are controlling the prompt at the end. Once the user clicks on the specified link, we create the prompt that it is sent to the endpoint from our function app that is subsequently handled by the secondary function I showed you earlier. It is the engage setting, and let's see what we have built with Terraform. Let's have a quick look. It's not that important to see how Terraform is working, but you can see that we can use, of course, Terraform to build our app. We have, I will pass it quickly, our main Terraform file that we create an application inside the resource group, some randomness for our names to be unique, application insights, the container registry, the app service plan and the Linux function app, and the container registry environment, Azure Container App environment. At the end, we're going to have a resource group with these resources: the application insights, the app service plan, this is by default created. Also, the failure anomalies smart detector alert rule is created by default. We are creating the app service plan, the container registry, the front end, which is our Azure Container App holding the React application, Element Analytics Workspace, the Container Apps environment, our function app that is the heart of our application, a storage account, and the user assigned managed identity for the environment apps environment to be able to pull the image from the container registry. Let's see what's happening here. Once I click on our front end app, I can use also a certificate and create my own uh, URL. We are presented with this screen. Of course, we can add authentication and so on. We can create prompts for our quizzes, for our tutorials, and of course, we can add a profile management into the React app. I didn't move on to create a profile. This is not the point of this application. It is just added for reference and to have a complete picture of what this application could be. Now, I started to build my React app because it's the final step. The final step because we need this URL. So the function apps should be ahead of the React app deployment. So I'm using Docker, as you can understand from the Azure Container Registry. I'm using Docker image. I have already built my image. Let's tag it. It's version 10. I'm tagging it, and now I'm going to push it to Azure Container Registry. It will not take much time. And the container apps image is pushed to Azure Container Registry and pulled from the container apps environment. So now we are able to see again our app here. So let's see what happens when we click Introduction to Algebra. I hope that the URL is updated. Not yet. Let's force the revision to grab the new container image we pushed just a minute ago. I hope that I didn't make the mistake not to save it. Yes, it is saved. So I have to restart the revision, and it will grab the new container from Azure Container Registry. Hopefully in a short moment we will be able to click here and have some input. Let's see if we have. No, the URL is not updated, as you can see in my environment. Let's have a look quickly in our code. Yes, and we have our response. You see what happened now? What happened when the user clicked here? Let's let's roll back our application. So let me close some windows so we can have better visibility, and we will return. We don't need the Terraform files. They're just to help us build quickly our infrastructure. Of course, the infrastructure as code is the future. We are not going to build by clicking on the portal. On most deployments, of course, sometimes it helps. So let's see what's going on in our application. Of course, we have created a React app, so we have to uh, populate our app.js file and add some nice CSS styling. You can see here. The app.js consists of our links. We have the navigation bar, home, tutorials, quizzes, and profile. Let's go to the tutorials, which we hit our link. This is how we build our tutorials part on our web page. You can see here this line that it is calling the environment setting, the React App backend URL. If it is not set, it is going to use the Docker Compose URL, which I will describe to you later. It is for a local test deployment. We can use it if we don't want to deploy to Azure, and we're going to use a Docker deploy um, file. So both backend and frontend are hosted into Docker, which is very convenient and useful to have a quick test on your application, and you don't have to deploy on Azure. Here we have the send engage request, which is our prompt. You can see here that it is using the backend URL constructed just in the earlier line, and it's using the endpoint engage. We are setting the user input as our prompt and write 50 words on introduction to algebra. Let's see if that was the case. And yes, Semantic Kernel was helpful because it communicated with OpenAI and brought back the input. This is the orchestration that we spoke about earlier in our introduction. Let's see the second link, basic of geometry. You can see here that the text has changed, and now we have input from OpenAI about geometry. I think we can also click the quiz on algebra. It's going to create a quiz about algebra. And yes, here you can see the response. You can see that I'm using React because it's very useful in this case, and we can have a lot of interaction with third-party apps, other components, and so on. So once more, let's see our final deployment and explain what's going on. For a local deployment, we can use Docker Compose, where Docker Compose is very easy to create and maintain. It does not need that much configuration, and it is a very simple file. You build your images, and then you are running a Docker Compose app command when in your local environment you can easily test your applications. Once we move out from our local deployment and we are happy with what we are seeing, we are moving to Azure. The backend is deployed as a Python function app. We can do this from our VS Code. It is very easy. You can check up the documentation of how we can create Azure function apps via VS Code. You can do it in a matter of minutes. The front end, which is a React app, it is created and pushed on Azure Container Registry as a Docker image, and then it is pulled from Container Apps environment. The Container Apps environment is creating a new application, which is the Learning Aid app that we just saw. The user is presented with the interface that we saw and we are seeing right now. This is our interface. We can add authentication, a lot of things. And the user is able to click on the tutorials, the quizzes, and get some information that is controlled by us. We have included in our code the prompts that we are sending to OpenAI. Semantic Kernel is the orchestrator integrated into our function app as a code. The code is taken from the Semantic Kernel GitHub repository and has been adjusted to work with my solution. So you can see here what it does. It is very smart the way that it's working. And let me show you quickly what I mean. Let's head over to the engage route here. First of all, let's see here the prompt config. We are configuring our prompt. We are setting the template and we are utilizing the chatbot semantic function. Finally, we are setting our variables. We can, of course, utilize memories, aka chat history for our deployment. And finally, bring back the output from the OpenAI being the response. So guys, I hope you liked our presentation tonight. It was my first one, so please excuse me if I made some mistakes speaking to you. I have to say I have some track, but I hope I will see you again with a new and exciting solution for the festive calendar. I was very happy to be here, and it was my honor speaking to you. Thank you, and have a great Christmas and festive season. Bye bye.